Hi, welcome to my channel Cloud with Girish. In this video, I'm going to show you how to create a simple DynamoDB table using AWS SAM and CloudFormation. Since this is a developer workshop, I assume you already have VS Code and SAM CLI installed. We need these software tools to develop and execute AWS SAM and CloudFormation template. We will create a DynamoDB table using SAM. We will create the same table using CloudFormation, and then we will create the table with GSI using CloudFormation. AWS SAM and AWS CloudFormation are two infra as code template mechanisms provided by AWS to create DynamoDB table using CLI. Infra as code brings the power of deploying your cloud resources without using the console and adds the ability to recreate the resources with ease as well as control the configuration of the resources. If you are looking to create a simple DynamoDB table, AWS SAM will suffice. However, if you are looking for a DynamoDB table with not only primary key, but also with sort key and global secondary index, then CloudFormation template is the way to go. Let's look at both the example. I'll create a customer table first using AWS SAM with customer ID as a primary key, and then we'll create another customer table using AWS CloudFormation that has customer ID as the primary key and then zip code as short key. I will then create a third table using CloudFormation that uses GSI, Global Secondary Indexing. Let's get started. We will review the SAM template, we'll review the CloudFormation template, we'll create and deploy tables using the template, we'll log into AWS console and review created table and index, and then at the end, once we are done with the workshop, we will delete the SAM CloudFormation stack. One thing I would like to call out that you can have up to 20 GSI per table. GSI is Global Secondary Index, and GSI can be added during the table creation or after the table has been created. Let's look at the SAM template for DynamoDB table. DynamoDB SAM serverless define a template that you can identify when you see simple table. AWS serverless simple table is defining a DynamoDB table. In property, I'm defining the table name, customer table SAM. It has a primary key of customer ID. I'm not using the provisioned table. I'm using on-demand feature, which is pay per request. If I want to provision the read and write capacity, then I will use provision throughput attributes. This is a very simple example of creating a very simple DynamoDB table. Let's look at the CloudFormation template for the same table. Here we have a CloudFormation attribute, the type AWS DynamoDB table. We have a table name. I have a billing mode, which is pay per request. There are attributes, customer ID and zip code. And then in my schema, I'm defining the customer ID and hash and the range, which is primary key and the sort key. Again, if billing mode is provision, then provision throughput, read capacity units and write capacity units are required. Since I'm using pay per request, the on-demand feature, then I'm not using the provision throughput, and that's why this is commented out. The third example I have for CloudFormation here, this one is with Global Secondary Index. Again, it's a CloudFormation template. You can tell it by looking at AWS DynamoDB table attribute, table name, billing mode is pay per request, same primary key, customer ID, sort key, and then this time I have a third attribute, city, that I'm going to use as a GSI, the global secondary index. So here is my schema. Customer ID and zip code is defined for primary key and sort key. And then under the global secondary index, you will see that I'm using the third attribute, the city, and this is how you can add GSI. Like I call out, you can have up to 20 GSI, so you can add more GSI if that's what your use case requires. Once I have this template all drafted, then I'll create and deploy the table using SAM CLI commands. It's the same SAM build command and then SAM deploy G command, the guided to follow the screen prompts. Once table have been created, let's log into AWS console to confirm that table indeed have been created. There are three different tables: customer table SAM, customer table CF, and customer table CF GSI. They all have the same primary key, as you can see from this view. And then in the next one, this is the third table that has also created a global secondary index. Let's see it in action. I'm in my IDE VS Code. I have template.yaml file. This is the template that's defining the SAM and CloudFormation resources. So let's look at it. It's the same table that I was talking about. It's using the SAM AWS serverless simple table, the customer table SAM. I got the customer ID. I have another table, which is CloudFormation. It's the AWS DynamoDB table. And then I have a third table, which is named as, let's look at it, customer table CFGSI, to indicate that this table has a global secondary index. You must have noticed that I have one template.yaml that has both SAM and CloudFormation resources, and AWS template allow this because AWS SAM behind the scene actually creating the CloudFormation resources. It just simplifies the entire process and number of line of code that you have to write. So this is the template that I will be using. Let's build this, SAM build. Once this is built, I can deploy it. I'm going to use guided so we can see the screen prompt. I'm going to take the default option. I'm deploying it in the US East 2 region. I'm going to take again the default choices here. I want to confirm before the stack is deployed. Yes, I want CLI to create the role. Rollback, control, save the configuration file. Yes. It's creating the change set. Once change set is created, I will have the opportunity to review it. And if change set is per my expectation, which it is, I have three tables here. I'm going to go ahead and say, yes, deploy this change set. These resources are now getting deployed in my AWS cloud. And in the screen, I can follow the prompt and see that create in progress, resource creation has been initiated. Some of the resources shown in green, create complete, customer table. So two tables have been created, and now all three tables have been created. Let's log into AWS console, and we will see that these tables indeed have been created. I have logged into my AWS console. I'm in DynamoDB dashboard. Let's look at the tables to validate that those tables have been created. And yes, as you can see, there are three new tables here. There is one table that's created using SAM code, another table that has been created using CloudFormation code, and then there is a third table that is also created through CloudFormation, but also has global secondary index. So if I look at the table, it has the customer ID as my primary key, and that's exactly what I defined in my code, so it looks good. If I look at my second table, it has customer ID as primary key, and it also has my sort key and zip code, and that is part of the code. On this one, if I click on index, there is no index because for second table, I did not create the index, but let's look at the third table. And here I have my customer ID as primary key, and then I have my zip code as sort key. But if I click on index, I also have a global secondary index created for me. So all these three tables have been created as we coded. So it works as intended. That's great. So all the tables have been created using infra as code, and this is the power of infra as code. I created these tables through the code. I can recreate these tables as many times as I want. I can create them in different environment, and if I don't need it, I can delete entire things using the SAM delete command, and that's exactly what I'm gonna do now for these three tables. So if I run our command SAM delete, it's gonna ask me that do I really want to delete these, and I'll say yes. It's now creating all the resources that I created using this SAM and CloudFormation template. So these tables will be physically deleted from my cloud, and that's again the power of infra edge code. So it's going to take a few seconds. So it really depends how many resources you are trying to delete. I just have three tables, so I don't expect it to take long, and it has deleted these successfully. With this workshop, developing and deploying DynamoDB table using AWS SAM and AWS CloudFormation has been successfully completed. At the end, I deleted the SAM CloudFormation stack so that I don't incur cost using these resources. Hope you enjoyed this tutorial. I'm working on some other interesting content on various AWS topics. These will be posted soon. Please don't forget to like and subscribe. Thanks for watching.